Hey guys, sorry I couldn't be here today. I did want to go over the notes with you though. So we are in Unit 6, Day 8. So today we are going to talk about something called the discriminant. But before we do, I want to talk about roots with you. So what are roots? Roots is just another name for x-intercepts. So roots are just a different name for x-intercepts. And quadratic functions can have different numbers of roots. So for example, this quadratic here has 2 roots because it has 2 x-intercepts. So we're going to say it has 2 roots. Not every quadratic has 2 roots. By the way, these are real roots, and we'll talk about why they're real in a second. So 2 real roots. This quadratic function has 1 real root because it intercepts the x-axis in one place. Some quadratic functions don't have any real roots. So for example, this guy right here has 0 real roots. But instead of saying 0 real roots, we're actually going to say something else. We're going to say it has 2 imaginary roots. You can't see them, but if you were to solve this quadratic equation using the quadratic formula, you would end up with a negative underneath the radical. And what happens when you have a negative under the radical? You end up with an I, which stands for imaginary. So when you have a quadratic like this, even though there's no roots that you can see, there's 2 imaginary roots. So what we're going to do is we're going to figure out what the discriminant is, and then we're going to use it to help us figure out what kind of roots we're looking at. But before we do that, we need to define a quick term, and that is rational. If something is rational, it means that the radical can disappear. So for example, the square root of 36 is rational because we can rewrite this as plus or minus 6. So the radical has disappeared. However, the square root of 18 is irrational because if we split this up into 2 and 9 splits into 3 and 3, then we can rewrite this as 3 radical 2. Since the radical does not disappear, oh, don't forget plus or minus. Since the radical doesn't disappear, then this is irrational. So rational means that the radical can disappear. We can simplify it to make the radical go away. Okay, so this is just an aside. We need to keep this in mind for later. We are going to learn what the discriminant is. So earlier in the unit, you learned the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is a special part of the quadratic formula, and it is the piece that lives underneath the radical. So this piece right here is the discriminant. So the discriminant is b squared minus 4ac. And what the discriminant does is it helps us describe the nature of the roots of a quadratic. So we learn the natures up here. We could have 2 roots, 2 real roots. We could have 1 real root. We could have 2 imaginary roots. So let's make a quick chart so that we can remember what the discriminant tells us. So the discriminant, which again is b squared minus 4ac, can tell us some information. Okay, so the first option that we have, and I'm actually going to add a little sketch to this, just a small one. Okay, so the first option we have for a discriminant is a positive perfect square. If b squared minus 4ac is a positive perfect square, then we are going to end up with two real rational roots. Remember how the discriminant lives under the square root symbol? If it's a perfect square, that's what makes it rational, because then the radical can disappear. So a sketch of this might look like this. It's going to intersect the x-axis in two places. Now, another discriminant could also be positive, but a non-square. So the nature of the roots would still be two real roots. So the sketch is going to look similar to the other one. It'll still intersect the x-axis in two places. The difference is these roots won't be rational, they'll be irrational, because if it's not a perfect square, then that radical is not going to disappear for us. The third option is 0. If there's a 0 under the radical, then we are going to have one real root. So an example of that might look like this, where it only intercepts at that one spot. Then our final option is a negative discriminant. If the discriminant is less than 0, then we are going to have two imaginary roots. Because when you have a negative under the radical, it causes us to pull out an I. So a sketch of this might look like this, where it is not interacting with the x-axis anywhere. There's two imaginary roots. So we're going to do a couple examples, and we're going to use our chart to help us determine the nature of the roots. So, first example. Say, for example, I told you to determine the nature of the roots of the following quadratics. So determine the nature of the roots just means describe them. So the first one we're going to look at is x squared minus 8x plus 16 equals 0. We don't have to solve this to determine the nature of the roots. We can just use the discriminant. Remember, the discriminant is b squared minus 4ac, and it's going to tell us everything about the roots that we need to know. So here we've got our, a is 1, our b is negative 8, and our c is 16. So when we do b squared minus 4ac, we are going to do negative 8 squared, which is 64, minus 4 times 1 times 16. And when you evaluate that, you get 0. So what does a discriminant of 0 tells us? Well, let's go back to our chart. A discriminant of 0 tells us that there's one real root. So it says tell us about the roots, describe them. Well, there's one real root. And that's the answer. And we're done. Let's try a couple more. Example B, negative 5x squared plus x plus 1 equals 0. We need to determine our a, which is negative 5, our b, which is 1, and our c, which is also 1. So we're going to do b squared minus 4ac because that's our discriminant. It describes the roots for us. Our b squared is 1 minus 4 times negative 5 times 1, which gives us, well, we've got a negative times a negative, which is positive. So 1 plus 20 equals 21. So that's a positive discriminant. What does that tell us? Well, is it a positive perfect square or is it a non-square? 21 is not a perfect square, so that tells us that we have two real irrational roots. That's important. Two real irrational roots. All right, two more. And you may want to pause the video and try these on your own before you check the answers. For C, we are going to do 8x squared plus 8x plus 3 equals 0. And D equals, or sorry, not equals. D is going to be 5x squared plus 6x plus 1 equals 0. So pause the video now and give these a try, find the discriminant, and then use it to describe the nature of the roots for each of these quadratics. Okay, now that you've given these a shot, let's check your work. For letter C, A equals 8, B equals 8, C equals 3. So you'll do B squared, which is 64, minus 4 times A times C. So 64 minus 4 times 8 times 3 is negative 32. Oops, negative. Snuck that in there. So when we go to our chart, a negative discriminant tells us we have two imaginary roots. And that's our answer. So for letter D, we do A equals 5, B equals 6, C equals 1. So B squared, 36, minus 4 times A times C gives us 16. And since that's a positive perfect square, we're going to have two real rational roots. It's rational because when you take the square root of 16, the radical disappears. So two real rational roots. And that's how you use the discriminant.